Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 182. Please turn to page 182. Today is our lesson number 244 and it is problem number 212 that we want to deal with. The problem 212 as it appears in the book, it says, as it appears in the book, it says 27. It says we have a two-digit number whose digits have been reversed. Digits of a two-digit numbers have been reversed. As a result, the new number that we obtain differs from the original number by, as the book says, 27. Question simply is, how much do the two digits differ? This is something that we already did yesterday. On day number 243, we have already done this problem, the problem that appears in the book. Today is a continuation of it. Same problem, 212, but it's a bonus problem. Instead of 27, let's make it 18. And as we learned the process yesterday, which I'm not going to go through in as much detail as we did yesterday. Yesterday's videos was 17 minutes long. I'm not going to go through obviously that much detail, but it's the same process. Here's what you do. If it's a two-digit number, say for example, if it's a 98, and if you say, if your x equals to 9 and your y equals to 8, as I explained yesterday, you cannot just write that as xy. xy in the language of algebra would mean 9 times 8. It will mean 9 times 8. It does not mean 89. 89 in the language of algebra, as we learned yesterday, is to be written as 98 is so called because it is made up of 90 and an 8. How do we express 90 given the fact that x is 9? Well, if x is 9, how do we express 90? Well, that's 10 times x. 10 times x. 10 times x is 90. Because x is 9. 9 times 10 is 90. Plus a y. This would be our integer. And when you reverse the digit, if 10x plus y becomes 10y plus x. And those digits have been reversed. Now it is 10 times the unit digit plus the 10 digit. Before it was 10 times 10 digit plus the unit digit. And their difference is whatever it is. Do you understand? So let's do it. Just like before, just like yesterday. So we have 10 times t, which is our 10 digit, and u, which will represent our unit digit. So 10 times t plus the u minus 10 times u plus the t, original number minus the new number, and we are told that differs by 18. And as we learned yesterday, that once you understand the concept, once you understand the process, this question should take no more than, well, I don't want to say too much, but it shouldn't take more than a few seconds. Because what it is, this number is always going to be some multiple of 9. That number is always going to be some multiple of 9. They will say 18 or 27 or 36 or 45 or something like, some multiple of 9. And as soon as you see the number, you multiply, you divide that number by 9, and that's how much the two digits differ. The answer here is 2. I just gave it away. 18 divided by 9 is 2. That's what we're going to find here. 10t minus a t is going to give us our 90. Similarly, a u here, positive u, I shouldn't be doing this thing because now it's difficult to read. A positive u here and a negative 10u, because this is negative outside, so it becomes negative 10u, will give us negative 9u, and that equals 18. You divide the entire equation by 9 and we find that t minus u equals 2. That's it. The two digits differ by 2. Question is, what could be the integer? What could be the integer in question? To which the answer is, we do not know. It's not a unique value. It could be any integer where the two digits happen to differ by 2. For example, it could be 31. 31 minus 13, you will find the difference is 18. You will find the difference of 31 and 13 is 18. If the integer happened to be 31, when you reverse this digit, it becomes 13 and the difference is 18. Similarly, it could be 42 and 24, or it could be 53 and 35, or it could be 60, 64 and 46, or 75 and 57, or it could be 86 and 68, or finally it could be 97 and 79. They will all differ by 18. All of these will differ by 18. So they couldn't possibly ask us what was the original integer. That wouldn't be possible because there is no unique value here. Oh, never mind. I was about to say something, but I caught myself. Never mind. For a split second, I forgot what I was doing here. I thought I was taping a GRE video. GRE is also another test that I do the tutoring for. And in GRE, in that exam, there is a new format of questions where more than one answer choices could be right. So if you were to give you a whole bunch of choices and there you are asked to check mark all of them that are possible, then they might give you 2 or 3 of these possible scenarios and you have to check mark every one of them. Same exact question, but the question will refer as, so the possible value of the original integer could be, and then they will give you answer choices. Do you understand? Anyway, that was it. We are done with this thing. Let's do the next problem. Enough of the talk. Let's do the next problem, which is problem number 213. Problem number 213. In 213, we are given a circle which we are told is tangent to both axes. We are also told that the distance from O to C is K. The question simply is, what is the radius? What is the radius? Obviously in terms of K. So here's our circle. Here are the 2 axes, and we have a circle that is tangent to both of the axes. Okay, it doesn't look like it's tangent, but pretend it's just one point here and here. So if you go this way and that way, that is the center of the circle. That is what they are showing in the picture with the letter C. And they must tell you somewhere the letter C represents the center. The circle with the center C, there you go, C is the center. And the distance we are told here is this distance O to C. This is O for origin, and this is C. This distance we are told equals K. Let's redraw this triangle here. Let's call it OAC. This triangle OAC. Let's redraw it here. So here's our O. Here's our A. And here is our C. This distance from O to C we are told is K. The question is, how much is the distance from O to A? Well, as we can see here, O to A is the same distance as from here to here. Let's give it a name here so we can talk about it. It's the same distance as B to C. O to A is same as B to C. When B to C, as we clearly see, is the radius. So O to A is the radius. Similarly, A to C is also radius. So this is radius and this is radius. So this is also radius. And it's a right angle triangle. It's a right angle triangle. Therefore, the circle with the center E shown above is tangent to both axes, is tangent obviously, and if the distance from O to C is equal to K, what's the radius of the circle in terms of K? So therefore, we apply the simple Pythagorean theorem, and we find that r squared plus r squared, this r squared and r squared must equal the square of the hypotenuse, which is K squared. R squared plus r squared is 2r squared, which equals K squared. Now we take the square root of it. The square root of K squared is simply K, and the square root of 2r squared is going to be, square root of r squared is just going to be r, and then times root 2. So it's r times root 2. That's our answer. R times root 2, wherever it shows like that. r times, we're not solving for k, we have to solve for r. Blast it. The question is not what is k in terms of r, what is k in terms of radius. The question is what is the radius in terms of k. So we have to solve for r. Nothing is going to change, same thing. So when we take the square root, this will become root 2 times r, and this will become k. And therefore r will be k over root 2. We have to divide both sides of the equation by root 2, and this root 2 cancels out, and we end up as r equals to k over root 2. K over root 2, whatever that is, which is answer choice B. The answer is B. That's it. I will see you tomorrow, okay? Bye now.